Okay, now comes the easy part. Now we're going to find the derivative of these inverse trig functions. So let's start with sine again. And what we're going to do, I want you to start noticing patterns because I want you to generalize the derivative of these inverse trig functions so that you won't have to recreate them every time like what we're about to do. So for example, if we say y is equal to the arcsine of x, and I'm asking you to find the derivative. So what we're looking for is dy dx. Okay? Well, we don't know how to do it right from here, but what we do know is that this can be rewritten as a sine function instead of an arcsine function. So this is the same thing as saying the sine of y is equal to x. We can find the derivative of sine of y equals x. We know that. On the left side with sine y, we can use the chain rule. And then on the right side, the derivative of x is pretty straightforward. So let's do that. So the derivative of sine is cosine, without changing the y, multiplied by the derivative of y, dy dx. I should have left more space, sorry about that. And then the derivative of x is just 1. So our goal here is to try to isolate the dy over dx. Okay, so if I isolate the dy over dx, I get 1 over the cosine of y. But that doesn't really help us because we have y in our answer still. We don't want to leave y in the answer, but what we do know is that y is equal to the arcsine of x. Okay, so let's do some rewriting. dy over dx equals 1 divided by the cosine of y, which is arcsine x. Okay, good so far, but I don't want you to leave it like that because you know how to find the cosine of the arcsine of x. So let's draw in a right triangle here. I know that the sine of some angle is x, that's opposite over hypotenuse, and this side will be the square root of 1 minus x squared. Okay, so if I find the cosine of that angle, that's adjacent over hypotenuse, I have just determined that the derivative of arcsine x is always going to be 1 over the cosine, which is the square root of 1 minus x squared. Okay, that's pretty good. It's pretty straightforward so far. So that's the derivative of arcsine x. I'd like you to find the derivative of arccosine x. Follow the same pattern I did and see if you can start noticing something that might help you for the future. So I want you to take a moment to please find the derivative of arccosine x. Pause the video. Go try. Okay, welcome back. Let's go through the same process I did before. We'll find the derivative. We'll rewrite this as a cosine function instead of a sine function. If I find the derivative of cosine y now, I get negative sine y dy dx equals the derivative of x, which is 1. dy over dx is 1 over the negative sine of y. But of course, we're not going to leave y in the answer. We're going to make that replacement. dy dx equals, I'm going to move that negative out here. So this is the sine of the arccosine of x. All right, right triangle. Now recreating it like this every single time, like trying to figure this out every single time, takes some time. So once we've found these values, we're just going to use them over and over again. I'll show you what I mean. All right, so if I'm looking for the sine of that triangle, opposite over adjacent is the square root of 1 minus x squared. So dy dx, the derivative of arc cosine is negative 1 over the square root of 1 minus x squared. Whoa, how come they're so close to being the same? Why is it that the derivative of arcsine is 1 over the square root of 1 minus x squared, but cosine is negative 1 over the square root of 1 minus x squared? What is making that happen? I hope you're actually thinking about that. The square root of 1 minus x squared part makes sense because we have x as one leg and 1 as the hypotenuse in both situations. So of course that third side is going to be exactly the same. They're both going to be a square root of 1 minus x squared. The negative came into play because the derivative of cosine is negative sine. So that's why we've got the negative for the arc cosine. But they still have the same value. It's still 1 over the square root of 1 minus x squared. All right, last one, find the derivative of tangent, and then we're going to throw this in for a loop a little bit. So find the derivative of arctangent. Go do it, hit pause, go give it a shot. All right, welcome back. We're going to find the derivative of y equals, oops, not that, of tangent of y equal to x. Okay, we can find the derivative of tangent, that is secant squared y times dy dx equals the derivative of x, which is 1. All right, if I isolate the dy dx is 1 over the secant squared of y, but of course we're not going to leave y in the answer. We have dy dx equals 1 over secant squared arctangent x. And we're not going to leave it like that because we can use a right triangle to find what we need. But I do know that tangent is x, so I do know that opposite over adjacent, that's x and 1. And the hypotenuse is the square root of 1 plus x squared. So this is really important to think about. In sine and cosine, the hypotenuse was 1, and one of the legs was x. That's why we have the square root of 1 minus x squared. But in this case, because we have tangent, which was both legs given, then the hypotenuse is the square root of 1 plus x squared. Okay, keep that in mind as you're going through all of this. Okay, now we need to find secant squared. We've talked about this before. Secant squared. And some of you will know an even shorter way to do this than what I'm about to, but that's okay. We know that secant squared is 1 over cosine squared of that angle. Cosine is adjacent over hypotenuse. So we end up with 1 over cosine squared, which is adjacent over hypotenuse. This is getting ugly. I'm going to back up a step because this is getting too ugly. We know that secant squared is 1 over cosine. So 1 over secant squared will just be cosine. Let's work smarter here, not harder. I was going to do it the other way, but that just gets ugly. Since secant squared is 1 over cosine, 1 over secant squared is just cosine squared. Let's just do it this way. All right, cosine we know is adjacent over hypotenuse. So adjacent over hypotenuse, and we square that. dy over dx. I square the 1 and I square the radical. So there's the derivative of arctangent of x. All right, let's put all of this together before we go on. Derivative, that's a nice color, of arcsine x is 1 over the square root of 1 minus x squared. You could always recreate it. I mean, we went through that whole process of figuring out where this came from, but I'm going to tell you in the future, it's going to be nice to just memorize this one. Derivative of arc cosine x is the same exact thing as sine, except negative, because the derivative of cosine is negative sine. And finally, the derivative of arctangent is 1 over 1 plus x squared, because we found the hypotenuse, and no radical because the derivative of tangent is secant squared. So it got rid of that radical for us. Okay, good. Now you won't ever have to find those again, but if you do have to, you know how. Well, what if I added a little twist to this? What if I asked you for the derivative of arcsin of 6x instead of just straight up x? So what I'd like you to do is actually take a moment, think about what you believe the derivative might be, and for this first one, I would like you to rewrite it and do this the long way. Don't use the shortcuts we found. Actually do this one the long way. And see what you come up with. Pause this. Go do it. All right, I hope you actually did it. I'm going to find the derivative. So the derivative of sine is cosine of y dy dx. And the derivative of 6x, keep this in mind, derivative of 6x, that inner function, oh, did I just say inner function? The derivative of 6x is 6. So if I say dy dx, then that's 6 over cosine y. Of course, we won't leave y in there because that's just silly. Cosine of the arcsine of 6x. And we're not going to leave it that way because we know how to build this right triangle. Wow, that was a horrible line. Let me try that again. Because we know how to build this right triangle. And we know that the sine of some angle is 6x. So opposite over hypotenuse and the square root of 1 minus, don't forget to square the 6 and the x, that's 36x squared. So the derivative of the arcsine of 6x looks a little bit different. I hope you're starting to generalize what just happened. How is this different when we have an inner function like 6x? How did the derivative of sine x change, or of arcsine x change? So based off of what you just noticed, I'd like you to try this one without using that long way. Can you tell me what the derivative of y equals arc cosine of 4x, let's just say, we won't get too crazy. What would that be without going through the long process that I just gave you? Give it a shot, and then to verify, try the long process. Okay, I hope you actually tried to think about what the answer might be. I'm going to use the long process one more time and then not again after this. So I'm going to find the derivative of the cosine of y equal to 4x. I end up with the negative sine of y dy dx equal to 4, so that's important. That's the derivative of that inner function. Dy dx equals negative 4 over the sine of y. We will not leave y in our answer, so dy dx equals negative 4 over the sine of the arc cosine of 4x. Okay, we'll use the right triangle. My right triangle is getting sloppier and sloppier. Opposite, oh no, this is cosine. Adjacent over hypotenuse, so the square root of 1 minus 16x squared. All right, finally, then the sine is opposite over hypotenuse. this derivative is negative 4 over the square root of 1 minus 16x squared. Let's see if we can generalize this to any inner function. So for example, if I just said, what is the derivative of the arc cosine of any inner function u? What would that generalized formula be? I hope you're writing it down. I hope you're thinking about it. And we'll do the same thing for tangent. Okay, so what I was noticing, and I hope you were noticing the same thing, is that this right side, which ended up being the numerator, was the derivative of that inner function. So the numerator is u prime. Oops, this is cosine, so in this case it'll be negative u prime. The denominator is still the square root of 1 minus, but where did that come from? That came from the Pythagorean theorem when we squared this other side, when we squared the 4x. That's how it got in that radical, is because we had to square that side of the triangle in the Pythagorean theorem. So it's the square root of 1 minus u squared. And then sine is positive u prime over the square root of 1 minus u squared. And tangent is u prime over 1 plus u squared. Those are really important to know. If you memorize those three, but the nice part is when you're memorizing, hopefully you're visualizing at the same time. That's going to make life a lot easier. Let me just do one last example of how we can use what we just figured out. So I'd like you to differentiate. Let's do f of x is 4x squared times the arctangent of 4x squared. Why not? Let's be interesting here. I'll just do this one through with you. If you'd like to pause, go ahead, but I'm just going to get started. So the first thing I notice is that I get to use the chain rule, and I get to use the product rule. So product rule because it's 4x squared times the arctangent, and chain rule because 4x squared is inside the arctangent. So let's use the product rule first. The derivative of 4x squared is 8x times arctangent of 4x squared without changing anything, plus, and I'm going to run out of space, so I'm going to go down to the next line, plus 4x squared, the first term unchanged, multiplied by the derivative of this. And we're going to use our little shortcut that we just came up with. So in this case, the inner function, the u value, is 4x squared. So I'm going to find that derivative. That's 8x. And then since this is tangent, this will be 1 plus u squared. So that would be 1 plus 4x squared squared. You can leave it like that, or you can simplify it to 16x to the 4th. It doesn't matter. If I simplify this one more time, this becomes 8x arctangent of 4x squared plus, and if I multiply these two fractions together, I get 32x cubed over 1 plus 16x to the 4th. Of course, that's more than I actually need to simplify, but I just wanted to show you what would happen if you did. All right, that's it. Your turn to go try a few on your homework tonight.